Thank you. Good morning. My name's Jonathan Beebe, and I'm going to talk to you about the integration of lifts into the Internet of Things and the need for an open standard information model to support that. The talk is structured as a discussion of what the Internet of Things is, why there's so much hype surrounding it. Then I will talk about lift systems integrated into the Internet of Things. There's some existing initiatives and some possibilities, but all of that leads to the need for standards for the integration. And I want to talk specifically about lift domain-specific standards. And finally, to conclude with an overview of the standard elevator information model. There's an enormous amount of discussion surrounding the Internet of Things at the moment. It can't be just because it's a way of connecting devices over the internet. There must be something more to it than that. Why is it now receiving so much attention? That's probably because the supporting technologies for the Internet of Things have reached a level of maturity where they can enable the mass production of the technology that supports it, and that brings about reduced cost of ownership, which accelerates the demand and the uptake. It's also the result of various technologies coming together at the same auspicious moment. So there's a sort of parallel with the smartphone, where all the different devices that are in a smartphone, GPS, camera, internet access, make it possible to do much more in the way of applications than simply any of those individual technologies would enable. The Gartner produce a report of emerging technologies, which they call the hype cycle, and it maps the progress of those and the uptake of those emerging technologies. And just over a year ago, they charted the Internet of Things at the very peak of inflated expectations. So it's receiving a lot of hype, which it may not actually deliver at the final conclusion. But 2 months ago, the Internet of Things was still at the peak of hype, but the integration of the Internet of Things has already begun its descent down the slope to the trough of disillusionment. But that's a good thing, because that means it's on its path to the plateau of productivity, where we will have stable, productive applications which are delivering the true value of the Internet of Things. In terms of definitions, where better to go than the Internet's own encyclopedia, Wikipedia. And whilst that does talk about connecting physical and virtual things, the important thing from my perspective anyway is that it mentions enabling advanced services, and it also talks about interoperable information. So this is key, because it's taking it beyond simply connecting the devices together. The IEEE talk about the ubiquitous nature of the internet, anything, anywhere, at any time. But actually, that's better expressed in terms from the point of view of the Internet of Things as accurate and appropriate information, the right time and the right place. And again, it's nothing new to address devices from remote locations. So the real value of the Internet of Things is enabling advanced services. The architecture, there are, because it's still evolving, there are different definitions of the Internet of Things and the architecture that it follows, but most of them have a layered approach, where the things devices are at the lowest level, but at the top level, there's this thing called semantics-oriented, which is all about how the information is described, what it means, and how it's organized, and the relationships between the different elements of information that is exchanged over the Internet of Things. Another interesting feature which is already available in the current Internet is search and discovery, so that applications, as they are running, can search and discover new devices, new services that were not known at the time these applications were developed. Moving on then to look at some commercial initiatives that already exist in this field. This is a survey that I did. It's not exhaustive. I just used corporate websites and press releases. A well-publicized application from ThyssenKrupp, the MAX system, analyzes real-time data from elevators around the world to assess the health of connected elevators and their components. So in that, the raw data from devices is being processed to produce meaningful information. So that's the semantic connection being implemented. A Connie press announcement talks about an application programming interface for third-party application developers. So I haven't seen this interface. I don't know anything about it, but I imagine there must be a description of the information that is passed through that interface to standardize it, and it also means that it's moving the information from the domain of lift systems into the wider world of other knowledge domains. And I also found flexi-page displays which give information to passengers on landings and in cars, which enables a two-way information flow between the users of the lift system and the lift system itself. So that's another aspect of the Internet, which is enabling public interaction with the devices. But then I thought, well, to really give some meaning to what the potential of the Internet of Things could mean, I let my imagination flow a bit and came up with the following suggestions. They're not designs, they're merely sort of musings. But supposing lifts could interact with social media. This is a tweet from a member of the public called Beth Allen, and it actually contains some useful information for lift systems, and there must be thousands, millions of similar tweets, some of them maybe not as well-mannered as that, about lift service, and if we could use that information to influence high-level control policies, or possibly even the lifts themselves could be made to generate tweets. So that's an example of how the public can interact and gain a sense of involvement with the lifts that they use in order to travel through buildings. Possibly, we hear a lot about smart buildings and smart cities, and we really need to have smart lifts that cooperate with them. So possibly we could predict demand in a short-term future demand from calendars, public and personal calendars, weather, transport availability, delays, to provide a personalized, intelligent, proactive service via mobile devices. So possibly you could use a lift much more like ordering a taxi. So it would know where you wanted to go, and you would know when it was about to arrive and which lift to get into. This is a quote from Ron Backer, who's an architect of a building called The Edge. And he says, it's Monday morning, you enter your office building, the elevator is waiting for you and knows on which floor you need to get off. And a final example I thought would demonstrate that the Internet of Things could enable new business models. So for example, maybe lifts or the buildings that they exist in could predict the short-term energy requirements of the lifts, and that could be supplied to the energy supplier in return for a reduced rate tariff. So actually the building owner or maybe even the lift manufacturer is becoming a vendor of information, not just lift systems. To make these sort of developments happen, semantic interoperability is a prerequisite. You can't interact with third parties, with external information sources, unless you understand what the information you're exchanging means. And that depends on domain-specific standards. So for any particular knowledge domain, you need a standard that defines what the information elements are for that domain. We are beginning to see the emergence of some domain-specific standards. They're usually defined in a formal technical definition by something called a schema or possibly an ontology. And there are a few examples, one which I've quoted here, the smart appliances reference, which defines simple elements of buildings like a light switch or a HVAC unit, but significantly not a lift. Within the lift systems domain itself, there are standards already known. The CanOpen lift standard defines the state of low-level data signals, but it doesn't really qualify for the title of semantic level knowledge. The building information model, and there are proposed there's a proposed standard for the lift industry, and also there are in other knowledge domains there are libraries which conform to a standard called Open BIM, which can be manipulated by various tools that produce specifications for Open BIM, but I'm not sure that it actually contains the rules of the relationships between the information, and it's based on the composition of lifts mostly, and doesn't cover the operational characteristics of lifts very well, I think. So I want to talk to you about the standard elevator information schema, which I developed about just over 10 years ago, and it describes the day-to-day operational characteristics of a lift system. And I think it's a key requirement for integrating lifts into the Internet of Things. It fulfills the semantic level requirement, and it includes processed information. So it's not just about the individual signals, but about demand profiles, journey plans, energy consumption. There are 4 types of basic elements of information described. Static data defines the parameters of the lifts and the building, so how many cars, which floors they visit, the speed profiles. This is taken from the specification itself, which is available on a website. I'll get to that in a minute. And there is another example. Dynamic data, which describes the current state of the lift, so that's changing all the time, so it's time-stamped. And that describes the registered calls that exist at the moment, a demand profile, which is based on the origin destination matrix. And the last type of information is event data, which defines the change of state within the lifts. And that is also time-stamped, and it has a context where the event was generated and possibly where it's destined to be received. As an overview, dynamic data and events are time-stamped, so they can be buffered. It's not subject to the speed of the network that's carrying the information. It's expressed as an XML schema document, or an XSD, which includes the rules and the relationships between the elements of information that it contains. And it can be processed directly by machines. Those are the things of the Internet of Things, to validate any information that is received. But it is also readable, so it provides its own documentation. And XSD editors can automatically generate software code to generate the data and to validate it in various languages. So it's not a protocol. It's not yet a service interface definition. It doesn't describe the functionality. It's not a conflict or a duplication of other standards, and it's not specific to the Internet of Things. It is an information model. It's constrained very rigidly to the scope of lift operation. It's free to download. It's free to use from that website, and it's published under this Creative Commons attribution license, and it's a powerful tool for integrating lifts into the Internet of Things. So what I've told you is that the Internet of Things, it goes way beyond addressing things. Its semantic level interaction is key. Lifts have a significant role to play. Standards are essential, and the schema for elevator information, the standard elevator information schema is open, available, and free. And I hope you will use it, and I would like you to comment on it and contribute to it if you feel that you're able to. Thank you very much.